Hi everyone! I'm going to be showing you how to reannotate and extend a gene, which is actually a lot less scary than it sounds. First, you're going to go to Expassi Translate, which is a web tool, and you're going to change the output to verbose and the genetic code to invertebrate mitochondrial, because in our case, we are working with the mitochondrial genomes of shrimp. And in a text processor, such as TextPad, you're going to want to open the FAST file from your Mitos results. In the Mitos results folder, it should be something like this. It says FAS. Open that up, and you should see something like this with the titles of the genes and their nucleotide sequences. We're going to scroll to find our gene of interest, which in my case is COX2. You're going to copy that nucleotide sequence and you're going to paste it into Expassi and hit translate. And you can see here it provides us with multiple different reading frames. And in our case, it looks like frame 1 is the one that we want to focus on because it has a lot of continuous red, which is a good thing. And we can see here that our gene starts with a start codon, which is great, but there's no stop. So our job is going to be to go into the whole genome of our organism, its nucleotide sequence, and search manually for that stop codon. And we are going to do this using a software called Mega, which is free to download. So once you have that all set up and installed, you're going to hit Align, Edit Build Alignment, create a new alignment. We're working with DNA, so hit DNA. And then in this new window, you're going to hit Edit, Insert Sequence from File, and you're going to want to upload the final assembly of your organism's genome. And it should look like just a giant string of nucleotides that will develop color in a minute. So going back to our FAST file from Mitos, we can see that the start codon is at the 1616 location, and the last nucleotide of the stop codon is at the 2287 location. So we're going to type in 2287, and you can see this is the last nucleotide of our gene that Mitos gave us, but we know that there's no stop codon there, so we are going to want to extend our gene. So we're going to go 1 over to 2288, and we're just going to want to take a chunk of this nucleotide sequence, and we're going to want to copy it and add it on to the end of our Expassi window and press translate again. And you can see here that this added a little bit to our transcript, and I went a little bit too far. This is the stop codon that we were looking at. So I have to go back into here and delete nucleotides until I am only seeing this first stop codon. So I'm just going to go by a few, and you can see that that got rid of them, and I have my stop. But I want to make sure that I don't have any excess nucleotides. I know that TAA is a common stop codon, so this G is most likely an extra. To check that, first I'm going to delete the G and translate again. So it still says stop, that's good. But just to make sure that this A is actually part of the stop codon, I'm going to delete the A real quick. And I know it's not extra because when I deleted that A, the whole stop went away too. So we're going to add that back. And you can see now that we have a beautiful gene. So we're going to take this sequence, copy it, and record it somewhere. I made a separate file where I pasted the nucleotide sequences for all of my protein coding genes. So I would paste it right here. And then you would also, in another table, it would be very helpful to record the start and stop numbers of your nucleotides. In this case, I know that this was my end codon. You can just, if you're having trouble figuring it out, you can look into Expassi and look for markers like that TGAAAG. You can see here we've got that TGAAAG right before our stop codon. So I would see that that is the real end of our gene. So I would record 2323 as the end, and then you would want to record the actual start and stop codons, and you're good to go.